Hi everyone, welcome to Z Intelligence. In the previous two videos, we looked at two very important counting principles, which are addition principle and multiplication principle. We looked at them separately and did some practice. And I know that a lot of you want to argue that the question we practiced in the previous two videos are not that hard. It's much easier than exam questions. One reason is we haven't done a lot of things about counting. The questions will be getting harder when we learn more counting techniques. And another reason is, in a specific video, when you see a question, of course you know which method should I apply. For example, in a video talking about multiplication principle, and of course I know that for all questions I'm gonna use multiplication principle. But in a real exam, no one's gonna tell you which counting principle you should apply. So how do I really know whether I should use multiplication principle or addition principle when we see a real exam question? So here, I'm going to tell you a very important criteria you should always follow when you see a counting question. You always want to begin a question with multiplication principle first. But what if multiplication principle doesn't work? Then this is the time you should think about addition principle, which you might need to divide the question into a few cases. So here, let me write down the basic process you should follow. So you should try multiplication principle first and see if you can solve the question. If you can solve it directly, that's the best. But in other situations, you might not be able to solve it by just using multiplication principle. So now, I should try to divide the question into a few cases and focus on each case separately. So this is basically addition principle. But here is the thing. Unfortunately, in some questions, you might need both addition principle and multiplication principle to solve the question. But you do still follow this process. We'll see some examples later on. So here is our first example of today. It's asking us to find the number of ways to spell the word math, M-A-T-H, wrong. But of course, I know that the number of ways to spell the word wrong will just equal to the total way to spell the word minus the way to spell it right. And of course, I know that the number of ways to spell it correctly will just be 1, because the only way to spell it right will just be M-A-T-H, this arrangement. So basically, if I can find the number of total ways to spell the word M-A-T-H, the question will just be solved. So remember that when we see a counting question, the first thing we need to think about is multiplication principle. My mission here is to spell the word M-A-T-H. Basically, I'm going to arrange the 4 letters M-A-T-H. So let's say these are my 4 places, and I'm going to fill the 4 places with the 4 letters. So I can just break down the process into 4 steps. And I'm going to choose a letter for each place separately. So of course, to ease our life, I'll just name all my places here. So in my step 1, I just need to choose a letter for my place 1. I have 4 letters, so that means I have 4 ways. So step 2, we'll focus on the place 2. I know that one of the 4 letters is chosen for my first place. For example, let's say M is chosen, which means I have only 3 letters left for my second place. Okay, so step 3, we'll focus on the third place. 2 letters are chosen for the first 2 places, so I only have 2 choices left. So for a third digit, I have 2 ways. So step 4 is for our last place. 3 letters are chosen for the first 3 places, so I have only 1 choice here. Basically, I have no choice, right? So in order to find a total way to spell the word math, we'll just multiply the 4 steps together, which gives us 24. But remember that we haven't done the question yet. The question is asking us how many ways to spell the word wrong, right? So what I need to do is, I just need to use the total number minus the only 1 way to spell it right, which gives me 23 as the answer. Question 2, this is a very classic type of counting question, which you want to color something. So let's see what's the question saying first. In this question, I want to color the 4 regions in the circle. As shown in the diagram, I have 3 color choices, which are red, blue, and yellow. But here, I have 2 important conditions that I have to satisfy both of them. The first thing is, each region is colored with exactly one color. So let's look at a diagram. Let's look at this region. Okay, so it's this one. That means that you cannot mix two colors together in the same region. And also, you have to pick a color. That means you cannot leave it blank. Okay, so let's look at the second condition here. It says no two consecutive regions have the same color. So let's say I have this region and this region. I know that they are consecutive because they share a common edge here. And these two regions must be colored with different colors. So let's say I choose blue for the first region, and then I'm not allowed to use a blue again in the second region. So same thing, I cannot use blue in this region either. Okay, now, so let's have an example to help us to understand the question better. I have red, blue, and yellow here. So if I use red to color the first region here, so now maybe I can choose yellow to color the second region. And I can use red again to color the third region. And for the last region, I can just use yellow again. That's like same style as BMW, right? So if you look at the first and third region, they both have red. That's okay because they are not consecutive, right? And someone else might also want to argue that the question says I'm going to use red, blue, and yellow. But where is the blue in my picture? I want to say that for this question, this is allowed. Because the question never says that I have to use all the three colors. So if I just use two of them, that's fine. Okay, so how many ways are there for us to color this diagram? Same thing here. We should always begin the question with multiplication principle first. Okay, so let's look at if multiplication principle alone works this time. I have 4 regions, so I can just name them 1, 2, 3, and 4. My mission here is to color all the 4 regions. So for sure, I can break down the whole process into 4 elementary steps. In step 1, I'm going to color the first region. I have red, blue, yellow, 3 choices, so that means I have 3 ways. Okay, and now let's look at step 2. We're going to color the second region. But here, how many ways I have? Let's say if I use blue for the first region, that means for the second region, I cannot use blue again. So this time, I only have 2 ways. I can only use red or yellow. Okay, now let's look at step 3. We're going to color the third region. So same thing here for number 3, it cannot be the same color as my second region. Which means if the second region is colored by red, that's just for example. So if I have red here, that means for the third region, I cannot use red again. So that means for the third region, I'm also going to have 2 ways here. Okay, and let's look at the last step here, step 4. Which in this step, we're going to color the last region, region 4. But here, there is a problem. I know that for region 3, I cannot use red. So that means I can use either blue or yellow. So let's just, for example, if I use yellow for the third region. For my fourth region, originally I have 3 colors, red, blue, and yellow. But since it cannot be the same color as region 1 and region 3, so that means I cannot use blue or yellow. So it seems like red is the only possibility left here. Okay, but let's think about this. If my third region is not yellow now, let's say my third region is blue. So this time for my last region, the only color restriction is blue. So I have 2 choices in my last step this time. That's really weird. For the same step, I have 2 different numbers of ways to complete a step. So it seems like multiplication principle doesn't really work this time. So now, remember what I said in the beginning of the lecture? When multiplication principle alone doesn't work, now we should try to apply addition principle. So how do we divide the case here? We just try multiplication principle, and we see that the cause for the problem in step 4 is whether if region 1 and region 3 have the same color. If they do, then I have 2 choices for my first place. And if they don't, that means I have only 1 choice for my last place. So remember that in the first video, we talked about this kind of situation. If something happens, then blah blah blah. If something else happens, then blah blah blah. when we see this kind of situation, we know that we should divide the case accordingly. So my case 1 will just be if 1 and 3, these two regions, have the same color. Okay, so now the question is actually exactly the same, except I have an extra information, which is 1 and 3 have the same color. So we find that we can just use exactly the same way as what we did when we're trying the multiplication principle. So in my step 1, I'm gonna choose the color for the first region. Of course, I have red, blue, and what else? A yellow? 3 ways, right? Okay, and step 2, we're choosing a color for the second spot. So for the same reason, right? If I use blue to color the first spot, so blue is chosen for the first place. Okay, so for the second spot, I can only use yellow or red, which gives me 2 ways. Okay, and now it's time for the third step, which we're gonna choose a color for the third region. Okay, so remember that in our first case, we have an extra piece of information, which region 1 and 3 have the same color. So that means I actually get no choice for region 3, right? Because I can only choose a color chosen for the first region. So in this case, if my first region is blue, my only one choice for region 3 will be blue. So we only get 1 way for third region. Now let's look at the last step. We're coloring the last spot. So because here my region 3 has the same color as region 1. For example, let's just say they are both blue. Okay, so now let's look at the fourth region. Originally, I have yellow, blue, and red. Okay, so 1 and 3 are both blue, so blue cannot be chosen again. So that means I can choose either yellow or red, which gives me 2 choices. Okay, so to finish our case 1, we'll just multiply every step together. We get 3 times 2 times 1 times 2, which gives us 12. But remember here, 12 is only the number of ways for one of our 2 cases. So if we haven't done yet, we have to do another case. In case 1, 1 and 3 have the same color. So in our case 2, region 1 and 3 should have the different colors. So I guess I'm going to redraw the diagram again. Okay, so for the second case, of course, the idea will just be very similar as the first case. So we're still going to use multiplication principle. In step 1, we're choosing the color for the first region, which we have 3 ways. This is because I have 3 colors. Okay, step 2, we're choosing the color for the second spot. We can just use the same idea. Let's just, for example, let's say I use blue for the first region. So for the second region, I will have 3 minus 1, which gives me 2 ways, which means 2 color choices. And now let's look at step 3, which we're gonna choose a color for the third region. It is important to notice that in case 2, 1 and 3, these 2 regions don't have the same color. So for the third region, originally I have blue, red, and yellow. But now since it has a different color as number 1, that means I cannot use blue here, which gives me 2 choices left. However, we still need to consider one more point. Remember that region 3 still cannot have the same color as region 2. Let's just say for region 2, I got yellow. So that means for region 3, it still cannot be yellow. This only gave me 1 choice left. So for step 3, I will just have 1 way. Okay, and now we're gonna finish up this case by view a color to region 4. Okay, so in this example, my third spot should be red, because that's my only choice. So let's look at the fourth region. I have blue, I have red, and yellow. So let's look at its 2 consecutive regions. One has blue, one has red. So that means for the last spot, I'm also gonna get only 1 way to do it. And remember our last step here, we're gonna find the total number in this case, which we're gonna multiply all the numbers here together. So times 2 times 1 times 1, which gives me simply 6. So with the help of multiplication principle, we got a number of possibilities in case 1 and case 2. To finish up this whole question, we just need to add these two cases together, which we get 12 plus 6, giving me the answer of 18. So, this question will be a good example of how we use multiplication principle and addition principle in the same question. Someone might want to ask that, I used both multiplication and addition principle, but why in the terminal step of the question we use addition instead of multiplication? To understand this question, you must need to know the logic behind this question. So let's say this circle represents the whole possibilities in the question. And the first thing we do is to divide the question into two different cases. So here, I divide the possibilities into two types, two categories. So what's a multiplication principle used for? Okay, so let's say for case 1, the multiplication principle here is a tool for us to find the number of possibilities or number of ways in the first case. So you can say that multiplication principle in this question actually serves the addition principle. So what we did is we used this tool to find there are 12 ways in the first case, and same thing, there are 6 ways in my second case. So of course, in order to find the total number of ways, we just need to add 12 and 6 together. Okay, so here comes our last example of today. In this question, I'm choosing 2 girls and 2 boys from 3 girls and 4 boys to make a line. So you can see in this picture, I use red to represent girls and blue to represent boys. The question is asking us how many ways are there to line up such that no 2 girls or 2 boys are consecutive. We can see there are a lot of information in this question. So it will be pretty helpful to list down some examples first. I have 7 people in total. Of course, they're different persons, so I can name them A, B, C, D, E, F, and G. Okay, so now let me first choose 2 girls. For example, I can choose A and C. And I'm also choosing 2 boys, let's say I chose E and F. So for these 4 chosen people, I want them to line up. But remember, there's one thing important. There is a restriction on how do you line up. Which 2 people have the same gender cannot stand together. An example will be A and C cannot stand together, E and F cannot stand together. So one example can be if I put A in my first place, I can put a boy in my second place. My next place should be girl, let's say I have C here. So the last place should be F. That's an example, that's a possibility. Okay, so now we understand it and we can do the question. So remember our tenet of this video is whenever you see a counting question, you always want to start with multiplication principle. Remember, our mission is to make the line, which the line consists of 4 people. So I will have 4 places here. Do you find that it's actually very similar as choosing number for each digit, that kind of question? Instead, in this case, we're choosing a person for each place. So first, of course, I'm gonna name each of my places here. And my step 1 will just be choosing a person for the first place. So for sure here, I have 7 people in total. So reasonably, I should have 7 ways to complete my first step. Okay, and now let's do our second step, which we're gonna choose a person for my second spot. But if you think about this, you're gonna find a problem here, because I don't know if my first place is a boy or girl. Let's say if I chose a girl in my first place, and remember the question states that 2 girls cannot be consecutive, so my second place has to be a boy, which I have 4 choices. But if I chose a boy in my first place, which means my second place has to be a girl. I have 3 girls here, so I have 3 choices. So the issue here, that will be to complete my step 2, I have 2 different numbers of ways. That's the same problem we faced originally in question 2. So here, I should know that it's a time to divide the situation into cases. Okay, how do we divide a case? From the experiment we just did, we found that the situation of the second place is dependent on who you chose in my first place. So I should just do the casework according to if I chose a boy or girl in my first place. So my case 1 will just be if I chose a boy in my first place. So here I'm just gonna draw the blue person. So how do I count how many ways are there in case 1? I think if you really understand the last example we went over, I think you should know the idea of using multiplication principle here. So our step 1 will simply just choose a person for the first place. Because in our case 1, I already know that the first place is a guy. So that means my only choices are these blue people. I have 4 of them, so that means I'm gonna have 4 ways here. Okay, and step 2. We're choosing a person for the second place. Because in my first place, let's draw the 4 places. If my first place is a boy, that means my second place has to be a girl. So that means I'm gonna choose a person from my 3 girls here, A, B, and C. So that means for this step, I have 3 ways. Okay, now let's look at the step 3, which we're gonna choose a person for the third place. Since the second place is a girl, so the third place has to be a boy. How many ways I have this time? Originally, I have 4 boys. But one of them is already chosen for the first place. So that means this time I have only 3 choices, which means I'm gonna have 3 ways to complete my third step. And my last step here, which I'm gonna choose a person for my 4th place. Since my 3rd place is a boy, my 4th place has to be a girl, right? So that means we're choosing a person from these 3 people. But same thing here, one of the girl is chosen in my step 2. So that means now I have only 2 choices. Okay, so we've done all steps in this case, and we can find the total ways. I can just multiply everything together. 4 times 3 times 2, times 3 times 2, which gives me 72. So this indicates that I have totally 72 ways in my case 1. And now we should consider our case 2. In case 1, the first place is a boy, so in case 2, the first place is a girl. This case is very similar as case 1, which you're gonna apply exactly the same idea, so I want you to try this case yourself. Okay, so here is the answer. I hope you get 72 as well for this case. Okay, so finally, to finish up this question, we should just simply add the 2 cases together. In the first case, I have 72 ways. And in the second case, I have 72 ways as well. So in total, I will have 144 ways. Okay, so that's everything for today. In this lecture, we practice 3 examples on addition and multiplication principle. And through this video, I'm expecting you to know 2 things. First, when you see counting question in your exam, which you have no idea initially, I hope you can always initiate the question by trying multiplication principle. And if it doesn't work, you should try addition principle instead. And the second thing is, you should know that in a lot of questions, you should apply addition principle and multiplication principle together, which in those cases, multiplication principle is usually a tool to serve your addition principle. Which means in order to count how many ways are there in each case, you might need multiplication principle to help you. Okay, and finally, don't forget to subscribe my channel because I heard that everyone who subscribed this channel got a 7 in their exam.